This topic is very much near to my research domain. As mentioned, I have recently submitted my PhD thesis. Quickly, we'll try to understand the micro kind of concept, so-called hybrid transmission line. So, to begin with, let us try to understand the basics. Though we all are aware and we all are comfortable with the terms, but still we need to understand how we are transferring from the conventional grid to a smart grid, right? And one of the kind of contributor is a hybrid transmission technology, which is not there in India, but it will be there in future. So we need to know what kind of technology it is and how we can incorporate the skills related to hybrid transmission technology. So in short, the major components of hybrid transmission line or even a separate AC or DC transmission line includes insulators, conductors, hardware fittings, tower foundations, and earthwork. So it's not a kind of a core engineering. It's a multidisciplinary domain, we can say, where we require civil engineers, we require electrical engineers, and all. Right. If we can predict, as my previous speakers has also mentioned some sort of statistical data, if we can predict our electrical power system from 2025 and beyond, let's say like central government has provided three goals to us: 2030 like 500 gigawatt renewable, 2047 as a developed country, and 2070 as a net zero. So we all are luckily, once we get in target, we all are working towards that. So futuristic peak demand, it will rise by 3 times. It will be reaching to 450,000 megawatt. Current installed capacity as such in March 2025, it is 47,500 megawatt. Network length in terms of circuit kilometers, it is 165,000. The inter-region capacity as per intrastate transmission system is concerned, it might reaches to 140,000 megawatt. The main transmission level will be a 1200 kilowatt ultra high voltage AC and 800 kV HVDC, and 765 and 500 kV HVDC will be a support transmission system, and the 400 kV line, which is like majority right now available in the country, will be utilized as a sub-transmission network. So this will be the prediction, and it has been predicted by Ministry of Power, right? So as per that, as a reference or base data, we can verify what are the future ready transmission grid, what are the challenges and strategic solutions we need to incorporate. We all know that right now a biggest concern to implement a new transmission line is right of way, right? Big concern, big hurdles. So rebuilding of transmission line in same servitudes, and there will be no charge in terms of required conductors and insulators. The insulator should be designed for hybrid AC-DC transmission line as per the requirement, as per the ratings. We'll have some case study, we'll try to justify that. Now, by availing certain technology, we can have an increased power transfer capabilities. We can have a better power flow control in line with line out concepts. Sorry, line in, line out concepts. The availability of land for new transmission line and public consent will not incorporated as far as hybrid line is concerned, and it is having a case cost-effective configurations. We had a real-time case study survey, and as per the overall cost configurations, it is much more cost-effective in comparison with development of new transmission lines. So towards resilience and efficient transmission infrastructure, it increases the capacity to transfer power. Like from same transmission tower, we now can transfer with the help of AC and DC. So a power transfer capability will increase. There will be a kind of less issue or less concern as far as right of way is concerned. Improvement in terms of efficiency and reduced transmission losses, because we will be incorporating HVDC. So in DC, there will be less transmission line losses. Enhanced stability and controllability of the system. The economic of transmission for long distance power will be more feasible, and grid infrastructure for the future is must. So a kind of new concept that we can incorporate. As far as design consideration is concerned, there are few parameters that we need to understand. Like as we are dealing with high voltage engineering, some sort of boundary conditions we need to take care as per IC/NIRP guideline, and as per IEEE concern. The right of way, the corona effect includes audible noise, radio interference, electric field effect, and magnetic field effect, kind of parameters we need to justify. And as we are moving towards a combining AC and DC on same tower, we need to incorporate their mutual impact. So more or less the presentation is towards research domain. It is like implemented in almost all developed countries like China, UK, US, Australia, even in South Korea. So some design parameters as far as electrical design concerns, we need to take care of this four design parameter, that is electric field, magnetic field, right of way, and corona. Inside a corona, we have radio interference and audible noise and ion charge for mutual coupling. So a kind of optimizing the hybrid transmission concept. So we have right now an existing grid which we need to incorporate and we need to modify it as per the requirement. So field effect limits on the design of hybrid transmission line overhead will be the key concern, which helps us to increase the power transfer capability, better power flow control and efficiency, and overall cost reductions. Analysis of sensitivity studies and design optimization. For safer side, we have taken a case study for 400 kV HVAC and 500 kV HVDC because both are very similar in terms of magnitude, and the overall right of way considerations and electromagnetic field concerns are very much near to each other. So that would be the initial stage, and subsequently we have raised the voltage by 765 and 800 kV HVDC. Then the field and corona effect kind of concept has been incorporated with different terrain conditions, with different ground level considerations. We have come up with some sort of solution. And the overall aim of this hybrid transmission concept is to produce a guideline to the utility engineers with an exemplified framework to design a hybrid transmission line for the possible improvement in the servitude utilization, because right of way is the biggest concern as far as Indian system is concerned, right? So these are few examples like how we can incorporate. Consider this as a conductor and assume that as a virtual tower where we have HVDC cables and HVAC cables. So different configurations are already been set up by European countries and by China. We have taken some case studies from them, and we tried to incorporate the same as per the Indian standard, as per the Indian reference voltage is concerned. So what we have proposed in that, we have a kind of proposed transmission, hybrid transmission model in line with line in, line out concepts, where on one side we have HVAC system and on other side we have HVDC, and we'll try to verify their mutual coupling effects, and we try to verify their right of way considerations. So this is a quite general case study that we have taken care with 400 kV HVAC conductor with double circuit line. So the upper conductors are HVAC in nature, and this is HVDC conductors. So again, the case like why we put DC conductor on lower side compared to AC, there is a philosophy in line with electromagnetic field concern. So that philosophy we have incorporated in the result table. These are the factor representations in line with electromagnetic field is concerned. This simulation has been incorporated in ANSYS software, and some portion has been incorporated with phase software as well. That is field and corona effect, one of the sub software of PESCAD. And certain results we have incorporated, like including consideration of SAC and without consideration of SAC, what is the value of electromagnetic field as far as that double circuit line is concerned. Now, by changing the DC conductor position from certain level to the maximum, what will be the change? This graph indicates that the effect of DC height and the distance between AC and DC conductor, because we are talking about mutual coupling between AC and DC. So that also been incorporated, and the distance between AC and AC conductor as far as double circuit line is concerned, as per multi-terminal circuits are concerned. This summary table incorporate that. If you can verify the fourth table with the DC height of 30 meters, and if we can change AC to AC distance from 4 to 10 and DC to AC distance from 3 to 8, we have certain number which incorporates the electromagnetic field value within range. So by incorporating that value, we can modify with the help of trial and error, and subsequently we can put some sort of algorithm with the help of artificial intelligence. We can prepare a neural network system, and we can justify the conductor positions as per the ICNRP guideline. So that range we have incorporated. So from for hybrid transmission line is concerned, for double circuit as per Ministry of Power guideline, the 400 kV double circuit line requires 52 meter of right of way, but as per our result is concerned, and it is authenticated, like verified with the uh, required publications, we secured that right of way within 46 meters just by changing the conductor position and the movement of conductor placements. With and without considerations are being incorporated. And subsequently, the magnetic field, it has little concern because magnetic field value limit as per the guideline is 100 microtesla, and we are getting results within 17. So it will not be a big concern as far as hybrid line is considered. And again, the side effect of corona, that is radio interference and audible noise. So as far as our result is concerned, the simulation that we secured in line with trial and error method, the mathematical calculations and the optimization algorithms, all results are very much fruitful and within range as per the Ministry of Power guidelines and as per CEA authority. So these are some representations like where we have changed the position from original to optimized value, and according to the position of RYB and a DC and positive conductor and a DC negative conductor, we can incorporate the spacing and we can verify the optimized results. And the main four parameter that we were supposed to discuss, the range should be within the range. Electric field we achieved 4.9, magnetic field 67, audible noise and radio interference again within the range of 49 to 50.33, and right of way as far as double circuit is concerned 52, and as per our results we achieved it at around 46.10 meter. So overall final results, if we can nullify and if I can conclude my presentation, by considering all the boundary conditions and constraint conditions as such in electric field, magnetic field, power transfer capability, and the subconductor diameters with the seg values and height of conductors, this summary table incorporate the total cost effectiveness of 30%. The overall efficiency that we achieved is almost around 80 to 95%, and the power transfer capability from both AC and DC is reaches to almost around 2500 megawatt with the existing infrastructure. So if we can follow the hybrid transmission models, definitely there will be a quite promising opportunity to fulfill the required demand, and we can transfer the renewable energy sources from load, and that is the main requirement. So yeah, let me just stop sharing my screen, and this is the brief about my presentation, though it is very specific to hybrid concept only because the previous speakers has verified the brief overview about the Indian power system and the overall grid and the recent advancement as far as AI and blockchain technology is concerned. But same thing we can incorporate with the hybrid models, and maybe we can add a detailing in line with the converter costings, the adaptations of robotic technology for inspection purpose in the existing line. So yeah, that's it from my end.